Okay, everyone, let's talk about solving quadratic equations by completing the square. And completing the square just means we're going to create a perfect square term where there wasn't one before. And there's a little trick we can use to do that. The upshot is that we can solve equations, of course, by using the square root property, and we can solve quadratic equations by taking the square root of both sides, which is using the square root property of equality, just like any other inverse operation, right? We have a squared term, we're going to take the square root of that term to solve for x. If we do it to one side, we have to do it to the other. That's all that means. But let's talk about the what of solving quadratic equations by completing the squares. I mean, the what is just that we're going to use a new method for to solve quadratics. And the how is by creating algebraically a perfect square term. And as far as applications, I mean, they're numerous. Physics, engineering, lots of stuff. In your case, probably the most applicable is that it will actually expand your analytic capabilities in a way that'll really very few other topics in math or in any other subject can. Okay, there we go. Capabilities. And the theorems, there are no theorems, but we are going to use the square root property. And the why is just, because math. And because exams. Right? I think we nailed it. Okay, so let's talk about then what do we even mean? First of all, let's solve a couple of equations just by using the square root property. You've done this before, you've seen this before, and hopefully you recognize it, but if you don't, here it is. Say you have 3x squared minus 4 equals 68. We're going to add 4 to both sides, right? We're solving for x. Add 4 to both sides, and we get 3x squared equals 72. And what is 72 divided by 3? Why, that's 24. Now we take the square root of both sides. We get x over here, square root of 24 over here. This can be simplified. We did this in geometry last year. Hopefully you did it in Algebra 1, but if not, we can get a little practice right now. This is, square root of 24 is the product of square root of 4 times the square root of 6, and this is a perfect square. So we get x equals plus or minus 2 times the square root of 6. Fun stuff, right? Shall we do another? I think we should. How about x squared minus 10x plus 25? That's a 5. Take my word for it. It's kind of the same deal, except that we have a perfect square trinomial here. There are only two factors of this trinomial, and they are x minus 5 and x minus 5, which we can rewrite as x minus 5 squared equals 27. And remember that the perfect square trinomial is going to take the form of a squared plus 2ab plus b squared, which is what you have here, except that you have a negative term for your middle your middle term, which just means you have a negative sign in your factors. All right, well now what? Take the square root of both sides, and we get x minus 5 equals plus or minus square root of 27. This can be simplified to plus or minus square root of 9 times square root of 3, and we get x minus 5 equals plus or minus 3 square root of 3. Except that we don't want to solve for x minus 5, we want to solve for x. X has to be isolated, so we are going to add 5 to both sides, and we get x equals 5 plus or minus 3 times the square root of 3. Easy stuff. Well, what happens if you are looking at a situation where you don't have a perfect square trinomial or a perfect square expression? Turns out we can make one, and we can do it by doing this. Where you have x squared plus bx, you can add b over 2, this is just your middle term, b, divided by 2, and square it. And remember, b over 2 works because you have in your perfect square up here, your perfect square trinomial, you have a 2ab middle term. So if this term is 2ab, then dividing by 2 is going to give you, and squaring is going to give you your third term. And we'll go over that a little bit more in class. Let's see how we use this though. Let's say we have x squared minus 2x. How can we turn that? And this is just an expression. Remember, this is not an equation. We're just adding a third term to our expression right now to get a perfect square trinomial. To do that, we would just add negative 2 over 2 and square it. And that gives us x squared minus 2x plus 1. Is this a perfect square trinomial? What are the factors? Well, if we square that, if we FOIL that out, we find that we do in fact get x squared minus 2x plus 1. And I will let you guys do that on your own. Shall we do another example, or shall we skip straight to the solving the equations? How about skip straight to solving the equations? How about this guy? Okay, I lost my notes. I had one queued up. Where did it go? Here we go. X squared equals 27 minus 6x. Okay, well, let's rewrite so that we have our variable on one side and our constants on the other. We're just going to add 6x to both sides to get x squared plus 6x equals 27. Let's complete this, the square on this expression. So we're going to say x squared plus 6x plus, our b term is 6, 6 divided by 2 squared equals 27. But if we add 6 divided by 2 squared to one side of the equation, we have to do it to the other. So now we have 6 over 2 squared on this side as well. We end up with x squared plus 6x plus 9 equals 27 plus 9. This factors very nicely to x plus 3 squared, and this very conveniently adds up to 36. If we take the square root of both sides, we're going to get x plus 3 on one side, and we're going to get 6 plus or minus on the other. Well, we haven't solved for x yet. We have an x plus 3 term, so we have to subtract 3 from both sides. We get x equals negative 3 plus or minus 6, which means we have to actually perform these operations to get our solutions, right? We're going to end up with two solutions. Negative 3 plus 6 is going to be 3. So x equals 3, or negative 3 minus 6 gives us x equals negative 9. And that's all there is to that. And we will do many more of these in class when next we meet. I do want to leave you with this last parting thought. This is similar to a chart that's in your book, but I like this a little bit better because it just reminds you to, if you can, try to get the coefficient of the x squared term to 1. So I would highly recommend writing this in your notes and committing it to memory, and refer to it often as we do our practice problems in the next few days until it becomes habit for you. All right.